Okay, example 4, we're going to evaluate these. So again, the rule that we're practicing is if you have the integral of 1 over u du, that will be equal to the natural log of the absolute value of u plus c. We're trying to see if we can get each of these problems into this form. So if you look at this problem, look at the denominator here. If we let u equal x cubed plus x, then the derivative of u with respect to x would be 3x squared plus 1. Thus, du equals 3x squared plus 1 dx. So, now I can substitute in. So this part here, this will be 1 over du, and this part here, this will be u, and then we can apply the rule. This would be the natural log of the absolute value of u plus c, where u is x cubed plus x plus c. So that would be A. Let's look at B. For B, let u equal tangent of x. So we have the integral of secant squared x over tangent x dx. So the derivative of u, the derivative of tangent of x is secant squared x. And I'm just going to move the dx to the other side. So now, this equals du, so I can make this 1 du, and tangent of x, that's u. So now we can apply the rule, the natural log of the absolute value of u plus c, where u is tangent of x plus c. So don't forget to plug that u back in when it's an indefinite integral. Alright, let's look at c and d. So again, we're trying to apply the rule, 1 over u du equals the natural log of the absolute value of u plus c. So for this one, let u equal x squared plus 2x. So the derivative of u equals 2x plus 2 dx. And then notice that you can factor a 2 out, so then you're going to have x plus 1 times 2 times x plus 1 dx. So we don't quite have this, but if we put a 2 here, and then to undo the 2 multiplied by 1/2, then we have what we need to substitute. We're going to have 1/2 the integral. All of this is going to become du. I'm going to make this 1 du all over x squared plus 2. That's equal to my u. So then I'm going to have 1/2 times the natural log of the absolute value of u plus c. And then again, don't forget to substitute u back in, which is x squared plus 2x plus c. Okay. Try B. So again, we're trying to use the rule 1 over u du equals the natural log of the absolute value of u plus c. So let's let u equal 3x plus 2. So the derivative of u would be 3dx. We don't have 3dx, but we can put a 3 in there and then multiply it by 1/3, so that those would undo each other. And now we can substitute. So this would be 1/3 times the integral 3dx is going to be du, so 1 times du. 3x plus 2, that's going to be u. Now we can apply the rule, which would be 1/3 the natural log of the absolute value of u plus c. And then again, don't forget to substitute u back in, which is 3x plus 2 plus c. Alright, example 5. Find the indefinite integral. We've got the integral of x squared plus x plus 1 all over x squared plus 1 equals dx. So if we tried to use the rule, the integral of 1 over u du equals the natural log of the absolute value of u plus c, and we tried to let u equal x squared plus 1, so du would equal 2x dx. That's not going to help us at all. So yeah, we're not going to get anywhere doing it this way. But what I can do long division. This is just a division problem. So we can see how many times x squared plus 0x plus 1. See how many times that goes into x squared plus x plus 1. So don't forget that place value folder there. So x squared goes into x squared 1 times. Well, 1 times x squared is x squared. 1 times 0x is 0x. And 1 times 1 is 1. And then remember, after you multiply, you're going to subtract. So this will cancel out. This would be x. That would be 0. So we don't need to write that. So now we just have x. Then we start over again. Does this x squared, it can't go into x, so this would be our remainder. So then I'm going to have 1 plus x all over the divisor, which was x squared plus 1. So now we were just able to show that this integral is equal to 1 plus x over x squared plus 1 dx. Or the integral of 1 dx plus the integral of x over x squared plus 1 dx. Alright, so we know this integral, that's just going to be x. And then this guy here, we're going to have to see if we can let u equal x squared plus 1, where du would equal 2x dx. I don't quite have, but I can put a 2 here, put a 1/2 here, so then this would be equal to du, so I'll make this 1 du, and then this x squared plus 1, that's equal to u. And so now I guess I can put plus c here, c sub 1. So then this is going to be x plus c sub 1 plus 1/2 the natural log of the absolute value of u plus c sub 2. And then x plus, I'll add these together in a minute, x plus 1/2 the natural log of u, where u is x squared plus 1, and then c sub 1 plus c sub 2 is just going to be some c, some constant value. So I'll put c there. That would be the answer for that one. Alright, so for this one, let u equal x plus 1. Then du equals derivative of x is 1, derivative of 1 is 0, so dx. Also, let's solve for x here. So let's make this x is equal to u minus 1. So now let's substitute in what we have. So 2x would be 2 times u minus 1. X plus 1, that's going to be u squared. And dx would be du. Then I'm going to have the integral of 2u minus 2 all over u squared for each of those du. Then let's see, I could factor out a 2, and u over u squared would be 1 over u minus 1 over u squared du. So then you could think of this as 2 times the integral 1 over u du minus 2 times the integral u to the negative second du. And now I can integrate. So this will be 2 times the natural log of the absolute value of u plus c sub 1 minus 2 times, this one would be u to the negative first divided by negative 1 plus c sub 2 where this would be 2 times the natural log of u, which is x plus 1. These negatives here would become a positive, and then this would be x plus 1 to the negative first, c sub 2 plus c sub 1. Those are just two constants that you add together. It's still going to give you a constant. That would be our answer for that one.